Welcome to Maths and Science Academy. Today we'll be looking at physics. So this is a physics question, which this is Newton's first law. So in this question we are given a 3 kg object that moves up an inclined surface at an angle of 15 degrees with a constant velocity. The coefficient of friction is 0.35. So we're supposed to determine the magnitude of the applied force. So since the object is 3 kg, so we'll go ahead and write the data down. So we'll write the data, and then we already know that the mass represented by the letter m is equals to 3 kg. And then now, going along with the statement, we are being told that this object moves up an inclined surface, and this surface is at an angle of inclination of 15 degrees, and this object is moving at constant velocity. So now let's stick to this term, constant velocity, and let us take a look at Newton's first law of motion. So Newton's first law of motion states that an object will remain at state of rest or will continue at constant velocity unless a non-zero or an unbalanced force is exerted upon an object. And we can see on this law we have this term constant velocity. So now let's go ahead and break down Newton's first law of motion, and then we are going to start with what is meant by the term state of rest. So what we actually mean about being at the state of rest, it means the object is stationary. So the object is not actually moving at all. This means that if the object is not moving, velocity is 0 and also acceleration is 0. This implies that the net resultant force on this object is actually 0 newtons. Now let's look at what is meant by constant velocity. So constant velocity implies that the object is moving at an unchanging speed, of which this simply means that V initial is equals to V final. So let's say, for example, at point A, we have this object that is moving at 3 meters per second, and the same object at point B is moving at 3 meters per second. So this implies that the velocity at A will be 3 meters per second, and velocity at B will be equals to 3 meters per second. So now, let's try to find the acceleration. We know that acceleration is delta V over delta time, or delta t, right? And we already know that velocity at A is equals to 3 meters per second, and velocity at B is also equals to 3 meters per second. Hence, velocity at A will be equals to velocity at B. V initial equals to V final. So we are going to say, let's say for instance, the time it takes for object to move from point A to point B will be equals to maybe, for instance, 4 seconds. So now where there is velocity, we know that delta V is V of B, which is V final, B minus V initial, which is VA, over delta T. So we know that velocity of B is 3, so it's going to be 3 minus the velocity at A, which is also 3, which is 3 minus 3 over 4, which is we given 4 seconds, and then 3 minus 3 is 0 over 4, which is eventually, therefore acceleration will be equals to 0 meters per second squared. And this implies that if the acceleration is equals to 0, therefore F net will be equals to 0 newtons, not 0 meters per second. It's actually supposed to be 0 newtons, 0 n. So from Newton's first law of motion, we can see that the object is at state of rest, or the object is at constant velocity. So now there is a commonality between the two terms, state of rest and constant velocity. What's common is that at constant velocity, the acceleration is equals to 0 meters per second squared in both cases, and the net force is also equals to 0 newtons. So let's go back to the question. Since we're given the 3 kg object, okay, we'll go back. M is equals to 3 kg, so that's our data, and then the object is 3 kg. It's a 3 kg object that moves up an inclined surface at 15 degrees with a constant velocity. So constant velocity actually means that F net is equals to 0 newton, and also the acceleration is equals to 0 meters per second squared. Hence we discussed. And we are also given the coefficient of friction, which is 0.35. This implies that mu is equals to 0.35. And then since we're given the coefficient of friction, there's this formula that I want you to know, which is frictional force is equals to mu Fn, whereby Ff actually means frictional force, and then the mu sign actually represents the coefficient of friction, and then Fn obviously represents the normal force. Now from here, I would like us to draw what you call the force diagram. So now drawing the force diagram, we'll look at the statement. The statement says that the 3 kg object moves up an inclined surface. So we'll just draw the inclined surface and then show the angle of inclination, which is 15 degrees. So now we'll draw the object by just using a box to just represent the object that is on top of the inclined surface, and then we'll draw the gravitational force. The gravitational force, it's moving exactly downwards, which means it's moving at the center of the earth, towards the center of the earth, which is exactly perpendicular to the earth, not the surface but the earth. So now we'll draw the normal force. The normal force is perpendicular to the surface. So I want you to differentiate between the two forces. The gravitational force is perpendicular to the earth surface, or the earth's core. It's moving exactly at the center of the earth. And then the normal force is perpendicular to the surface of the object, not the surface of the earth but the surface of the object. So now we'll draw the frictional force. Remember, this object, it was stated that it moves up an inclined surface. So now the frictional force will go the opposite direction of the direction of the motion of the object. And then we'll draw the applied force. As we know that the applied force is pushing the object upwards, so it's moving in the direction of the motion of the object. And then now we'll try to draw what you call a free body diagram or a vector diagram. A free body diagram, it's the object is shown by a dot, and then we'll draw the component of FG. Components of FG, we have FG perpendicular and FG parallel. And I want you to make sure that you don't confuse the angle of inclination. So the angle of inclination of in the components of FG, it's exactly on the y-axis. Hence, that will eventually make FG perpendicular be FG cos theta, or cos 15 degrees. And then we have FG parallel, which is parallel to the surface of the object. So now we can eventually tell that FG parallel will be FG sine 15 degrees. So now from the information, we can easily draw the free body diagram. So now we'll draw the normal force going upwards, FG perpendicular going downwards, and we can see that Fn and FG perpendicular, those are the forces in the y-axis. So we already know that Fnet in the y-axis will eventually be equals to 0, since we already know that Fnet is equals to 0. And Fnet we have the forces in the x-axis, which is Fg parallel, frictional force, and then also the force applied. And then Fg parallel going to the left hand side, and also the frictional force going in the same direction as Fg parallel, and the force applied going to the right hand side, forcing the object to move up the inclined surface. Now let's start by calculating the frictional force. So now calculating the frictional force, we already know that we have this formula called Ff equals to mu Fn, whereby Ff is the frictional force, equals to mu as the coefficient of friction, and then Fn as the normal force. And then we're already given that the coefficient of friction is 0.35, and then we're supposed to find the frictional force, and then we also don't have what you call the normal force. So we can see that from the force diagram, F net y consists of Fn and Fg parallel. So we can use F net y. Since we know that here we are using Newton's first law, we know that F net y is equals to 0 newtons. So F net y, since we're taking upwards as positive, Fn will be positive and Fg perpendicular will be negative, equals to 0. And then from here we'll make Fn the subject of a formula by taking Fg perpendicular to the right hand side. And then we already know what is the formula of Fg perpendicular. Fg perpendicular is equals to Fg cos 15 degrees. So Fn is equals to Fg cos 15 degrees. And then we already know that Fg, the gravitational force, is given by the formula mg, which is mass times the gravitational acceleration. So we'll substitute the mass of the object, which is 3 kg, times the gravitational acceleration, which can be found on the formula sheet on your exam paper, which is given by 9.8 meters per second squared, and then cos 15 degrees. Now going back to calculating the frictional force, so where there is Fn, you'll substitute 3 times 9.8 cos 15 degrees. So we'll go ahead and write frictional force is equals to 0.35 times 3 times 9.8 cos 15 degrees, and then you'll go ahead and punch this on your calculator. So giving us frictional force equals to 9.94 newtons. So now we'll be looking at all the forces in the x-axis. So we already know that the net force is equals to 0, so therefore the F net on the x-axis will eventually be equals to 0 from Newton's first law. And then we're taking to the right as positive, so Fa, the force applied, will be positive, and then the Fg parallel will be negative, and also the frictional force will be negative. So Fa minus frictional force minus Fg parallel will eventually be equals to 0. And then we'll take the frictional force and Fg parallel to the right hand side, making the force applied to be positive, since we are supposed to determine the magnitude of the force applied. So now we already know what is the frictional force, which is we already calculated it. Now we have to calculate Fg parallel. So by calculating Fg parallel, we already know that Fg parallel is given by the formula Fg sine 15 degrees, which we can rewrite it as mg sine 15 degrees, right? Now let's go ahead and substitute. We already know that frictional force is 9.94 newtons, and then we know that the mass of the object is 3 kgs, and then we know that g as the gravitational acceleration is 9.8 meters per second squared, and then sine 15 degrees. So Fa is equals to 9.94 plus 3 times 9.8 sine 15 degrees. And then punching that on your calculator eventually gives us 17.55 newtons.